In this video, I'm going to derive the formula for the sum to n terms of a geometric series. This is a general geometric series I have here. Remember, we always call the first term a, and the common ratio is r. So the second term is going to be a times r, the third term is going to be a times r squared, next term will be a times r to the 3, and so on. The nth term of a series is given by ar to the n minus 1. So that's going to be the last term in this series. And to do this derivation, we do a little trick. What we do is we multiply both sides of this equation by 1 minus r. So multiplying both sides of the equation by 1 minus r, that I'm allowed to do that because it keeps both sides equal. As long as I do to both sides, the equation stays true. And for the next few lines, we're going to concentrate on this right-hand side here. And we're actually going to expand these two sets of brackets. Now, that's a bit hard to get your head around when you've got this massive long bracket here, but the process is going to be the same as for any sort of binomial expansion that we did earlier. I'm going to break it into two steps though to help us out. So the first thing I need to do is go 1 times this whole bracket. So I'm going to write it as 1 times this guy, a plus ar plus ar squared plus dot 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 plus ar to the n minus 1. Then I'm going to do my minus r times the same thing. A plus ar squared plus dot 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 plus ar to the n minus 1. And finally we're going to expand each of these brackets, so the thing at the front needs to times by each thing in there. And this one's easy because 1 times anything just keeps it the same. So 1 times a is a, 1 times ar is ar, and so on. It's going to go up to ar to the n minus 1. With this one, it's a little bit more difficult, but not too bad. It's a negative, so everything is going to turn negative because these are all positive. So all the results here are going to be minuses. R times a is ar, minus r times ar is ar squared, minus ar cubed, and so on. And the last term in this case, actually I'll do the second last term. The second last term, so before this would be ar to the n minus 2. Multiplying by r, I'm going to get ar to the n minus 1. The final term is r times ar to the n minus 1. It's going to be ar to the n. Okay? And if you have a look at this whole long expansion here, we'll notice something really nice. There's an ar here, and there's a negative ar over here. So those two are going to cancel each other out. Similarly, we've got an ar squared here. It's going to cancel with this negative ar squared. And that's going to continue. The next term here, even though we haven't written it in, would be ar cubed, and there's an ar cubed, and so on. There's an ar to the n minus 1 here, and a minus ar to the n minus 1 there. Everything here is going to cancel except for the first term and the last term. So the result of this massive expansion is simply a minus ar to the n. Now that's pretty nice, but we can't forget that on the left hand side we've got a 1 minus r times Sn. We just want the Sn on its own. So we need to get it on its own. To do that, we're going to do the same thing we do with any equation. We're going to divide by this thing that's multiplied by it. So I'm going to take a minus ar to the n, and I'm going to divide it by 1 minus r. And finally, just to tidy up, there's an a in both terms on the top, so I can factorize that out. And we get this formula here. Sn equals a outside of 1 minus r to the n over 1 minus r. Now that's one form of the formula. You will sometimes see it written slightly differently. I don't usually bother doing it in a different way, but sometimes people will write it a little bit differently. This works really well if r is less than 1, because what happens is you get 1 minus a number less than 1. This thing stays positive. You'll also get this thing staying positive. It'll be a nice result that you get out of it. So some people, they like to have a different form for when r is bigger than 1, because it's a bit more natural to take the bigger one and then subtract the smaller one. So some people like to swap these two around, and this is how they do it. If you take Sn, okay, which was this formula we just derived, you actually multiply this by minus 1 on minus 1. Now we're allowed to do that because anything divided by itself is just 1. I'm really just timesing this fraction by 1 in disguise, so it's not going to change its value. But if we do that, multiply minus 1 on the top, multiply it on the bottom, I'm going to get this on, okay, 1 times minus 1 is minus 1, minus r times minus 1 is plus r. Now on the top of the fraction here, I can multiply the minus in and do a similar kind of thing to what I've done on the bottom. And then to tidy up, okay, we can just swap the order of these two terms. Okay, and you can sort of see here, okay, that result there is exactly the same as the one we had before. The only difference is that these two are swapped around. And you can use either form. I prefer this one because it looks like the sum to infinity formula that we're going to talk about later. And both will always work. It's just if you choose this one when your common ratio is bigger than 1, you won't have to deal with the negative signs that are involved. But either one's fine, or you can learn to use both of them and choose which one you use in different circumstances. And that's where the sum to n terms of the geometric sequence comes from.